Hi everyone, my name is Keval Gala. I'm a freshman at Carnegie Mellon University, and I'd like to present you my term project from 15112 Fundamentals of Programming and Computer Science. So before I go into the code itself, I'd just like to show you the upper level directory that houses the file. You can see there are a number of images that the code uses, many of which I edited in Photoshop, and there's one sound file. So I wrote the code in Python, and the module that I used was Pygame. So my project is essentially a badminton simulator, and I would like to give credit to my mentor Christian Pedersen for helping me out with it. I completed the project in approximately 3 weeks, and my main goal behind it was to create a simulator that looked somewhat like Wii Sports Tennis in that there should be a 3D view and one that was easy and intuitive to play, but also reasonably challenging. So um, here you can see these are just some of the modules that we import to make the code work, the images and sound files that I mentioned. So let me just walk you through some of the classes, and then we'll run the code. So I have a score class to keep track of the score in the game. The court class just keeps track of the measurements of the dimensions of the court. The light source is something that allows us to create a shadow for the shuttlecock, which I will show you when we run the code. The shuttlecock itself takes care of its own movement and draws itself. The human class is important because that's what the user will control. And of course the AI class is what they play against. Then you have a racket class, which is what the human player uses to hit the shuttlecock. And you have the menu, which opens up prior to the game. So it has its own main loop, as you can see. And then, of course, the game class is the one that has the large main loop that controls most of the game. So, and of course, a drawing function. So here are some helper functions that we use. And now let's go ahead and run our game. So as you can see, the menu pops up. You have three options: how to play, settings, or match. So let's just go into how to play first. So in this menu, I just present the keyboard controls and the mouse controls, and this is actually really important because when I did my competitive analysis, I found that there were badminton games that existed online that used keyboard-based controls to move the player, but I found that these were really awkward and hard to use. And so one of the main features that I wanted to implement in my own design is a mouse-based movement system where you can move the player with the mouse, as I'll show you. However, hitting the shuttlecock is done with these four keyboard controls. Of course, the objective is to get to 11 points. So in settings, we just see a little bit about gravitational acceleration. These are just some facts behind how the game works. The light source that I'll mention is positioned above the center of the court. You don't actually see it. It's just a value that allows us to calculate the position of the shadow. So let's go back, and now we're ready to start a match. So if you go into match, you'll notice I'm moving this player with my mouse. So this is what I'm talking about. The player is constrained to their side of the court, but within that I can move the player freely with the mouse. And this is a lot easier than using the forward, back, and left and right controls on the keyboard. Before I go ahead and serve the ball, I just want to point out the effect of the light source on calculating the position of the shadow. So if you notice, the white shuttlecock has a black shadow slightly below it. And if you look very carefully, you'll notice that this shadow moves relative to the shuttlecock as the player moves from side to side. It's very subtle, but it does move relative to the shuttlecock. And this is because using triangle similarity, you can calculate where the shadow should be relative to the shuttlecock using the coordinates of the shuttlecock and the light source. And the reason for this is it allows us to create a more believable 3D game in what is inherently a 2D module. So the math behind it has to be done correctly if you want your game to make sense and look 3D. So let's go ahead and serve the ball. You'll notice the sound effect comes into place. So there, the AI was not able to return it, so we got 1 point. So now you can see how gameplay proceeds. So as you noticed, there were 3 ways to hit the ball. You can either hit it straight, to the left, or to the right. The serving itself is always done by the human player, and there is an element of randomness in it. So now if I were to let the shuttlecock drop like that, the CPU gains 1 point. But notice that the human player is still serving. So I'm just going to go ahead and get to 11 points to show you what the win animation looks like. So we're at 9, okay. And also one thing to note is that the net is not part of the court. The net has been, this net image has been overlaid on top of the court so that you can use transparency to create a, to differentiate between objects that are in front of the net and objects that are behind it. Okay. So here's the win animation. So human wins. Alright, thank you very much for watching, and I hope you enjoyed.